Hi and welcome to the solution video of this paper 42 of October-November 2023. If you like this video, please share with your friends and subscribe to Math United. I'm solving this paper without a marking scheme, so if you find any improvement area, you can comment on it and let me know. So let's get started with question number 1. A block of mass 15 kg slides down a line of greatest slope, slides down, so it is coming down. So let's say this is the line of greatest slope, inclined plane. So suppose block is here, it is sliding down. The top of the plane is at vertical height of 1.6. so if it is sliding down from here, so this height is 1.6 meters above the level of the ground. Okay, this is the level of the ground. The speed of the block at the top of the plane is 2 meters per second. So u is 2 meters per second here, and the speed of the block at the bottom of the plane is 4 meters per second. V equal to 4 meters per second. Find the work done against the resistance. So they're asking what is the work done against resistance to the motion. Okay, so we can use the energy formula in this, which is that the work done by the applied force is the sum of work done against the resisting force, the change in kinetic energy and change in potential energy. The sum of these three is the work done by applied force. Since they have clearly said that this is sliding down, that means nothing is continuously pushing it down. Since there is no force which is pushing it down continuously, there is a natural force due to gravity because of its weight which is applying on it, but it will be taken care by delta PE. Change in potential energy is the same force, work done by the same force which we call delta PE, so we will not consider that one. So there is no applied force on this, no physical touch, so 0. This we have to find out. And delta KE is, the formula for that is half m mass final velocity minus initial velocity. This is the change in kinetic energy. Then change in potential energy is not half, pardon me, m g final height minus initial height. All right, and we'll just substitute things now. So 0 is equal to no applied force is equal to resistive force plus half m is 15, v is 4, u is 2. So clearly kinetic energy increased because final is more than the initial. Plus 15, g is 10, hf final height is 0 and initial height was 1.6. So we'll get a negative change in potential energy, which means it will be positive on the other side. So let's bring this one, 150 times negative 1.6 minus 240. So this will be minus 240. This is 7.5 and this will be 16 minus 4, which is 12. So 12 and 7.90. So this is 90 minus 240 will be minus 150. So 150 goes there, becomes positive. So 150 equal to WR. So work done against resistive force, resistance, is equal to 150 joules. Alright, let's move on to question number 2. The diagram shows a smooth ring R of mass m kg threaded on a light inextensible string. A horizontal force of magnitude 2 Newton acts on R. Okay, it's not written here, so 2 Newton. Okay, the end of the string are attached to fixed points. Okay, the angles are 30 degrees and 40 degrees with the vertical. In both cases, the ring is in equilibrium. Nothing is moving. Find the tension in the ring and find the value of M. Okay, so let's do what? Let's say that this is tension here in this direction, and it will be the same string here, so this will also be same tension. Okay, so the component of this tension in this direction will be because this angle is 30, this angle will also be 30 because of being alternate angles of parallel lines and a transversal line. So this will be T cos 30. The component of T will be T cos 30 in this direction because the angle is here. Wherever is the angle with the main force, that component becomes cos. Similarly here, because of this 40, this angle will be 40 degrees and this component will be T cos 40 degrees. Additionally, we have m kg mass of this ring. This will be also in this direction. So we'll have 10m, another force, 10 times m in this, which will be the weight of the ring. Okay. Now these components will be, because this is cos component, on the other side of the force, it is always sine. So it will be T sine 30 for this one and T sine 40 for this one, this force T. Okay, so we have all the components now. So let's equate, because it's an equilibrium, the forces are equal. So let's start with this one. 10m plus T cos 40 will balance out T cos 30. So 10m plus T cos 40 will be equal to T cos 30. So 10m I can keep here, equal to T cos 30 degrees minus T cos 40 degrees. So let's take T common here. So 10m equal to T cos 30 degrees minus cos 40 degrees, and m equals to T cos 30 degrees minus cos 40 degrees divided by 10. This is our equation number 1. Let's go to the other component, which is T sine 40 and T sine 30. Their sum should be equal to 2 newtons. So T I will take common from both. So sine 40 plus sine 30 plus sine 30 equal to 2. So we got T straight away. Did they ask? Yeah, they asked the tension, asked us tension also. So T will be 2 divided by sine 40 plus sine 30 degrees. Let me use my calculator to find out how much is this. By the time I do this, I would request you to like this video and share with your friends. I think I am the first person to solve this. So if you really like it, give it a thumbs up and subscribe to Math United. Thank you. What I'm getting is 1.75 newtons. Okay, now we need m also, value of m. So let me do it here. M equal to T is now 1.75. 1.75 times cos 30 minus cos 40 and divided by 10. Just every number is with us. We'll put this also in our calculator, and in this case we get 0.0174977, which is almost 0.0175 kg. Okay, so got the solution of number 2 also. Okay, number 3. A block of mass 10 kg is on rest on a rough plane inclined at 30 degrees. Okay, to the horizontal force of 120 newtons is applied to the block on at angle 20 degrees. So it is not going in the direction of motion, it is upwards 20 degrees. Okay, there is a force resisting the motion block and 200 joules of work is done against this force. Okay, so work done against resistance is 200 joules. Okay, and 5 meter. Okay, so distance traveled is 5 meters. So we can find Fr in this case because we know that Wr is equal to F resistive force times the distance travels. So 200 equal to Fr times 5. So resistive force is 200 divided by 5, which is 40 newtons from the rest. Okay, find the speed of the block when it has moved a distance of again 5 meters from the plane. So good, we can use energy as well as force. So since I found force already, let me try to use this. So in this direction we'll have the cos component of 120 because angle is here again. So 120 cos 20 degrees. Okay, there will be a resistive force which is friction, right? Because of this the normal contact force will change, but whenever they give you a force, resistive force, it includes friction, it includes air resistance, includes everything. So that there is no need to go to this component anymore. Just 120 cos this component is enough. So let's not confuse ourselves. So we'll write 40 Newton, which is the resistive force in this direction, and also there will be a component of the weight which will be 120 sine 30 degrees. Okay, so it is always sine component in this direction because this is the cos component of the weight here in this direction, 120 cos 30, but we are not going to use it because Fr is given to us. So we'll get the acceleration. What are they asking? Speed. So we'll get acceleration because of this, because we know that net force is what applied force is subtracted the resistive force in the direction of motion. Okay, so F net will be the mass, which is 10 kg, times acceleration, applied force 120 cos 20, and there are two resistive forces. One is this 40 newtons, so minus 40, and is 120 sine 30 as well. So 10A is equal to 120 cos 20. Sine 30 is half. So 120 multiplied by half is 60, and 40 it will be minus 100. So we can straight away find acceleration in this case, which is 120 cos 20 degrees minus 100 and divided by 10, which is the coefficient of A here. So what do we get here? We get 2.276 meters per second square. That is the acceleration. Okay, but our job was to find the speed of the block when it has moved 5 meters up. Okay, so we know it started from rest. So U is 0, V we have to find, A we know is 2.276 meters per second square. We know S also, it moved 5 meters. So we can find V easily by this. V square is U square plus 2AS. V we want to find equal to 0 square is 0 plus 2 times 2.276 times A. Okay, done. And S is 5. So V square equal to 2 times 5 is 10. 10 times this will be 22.76. Square root both sides. And we get the velocity speed after 5 meters, which will be how much square root of this? 4 point something. Let me use my calculator. By the time I do this, I request you to kindly subscribe to Math United and give this video a thumbs up. I'm getting 4.77 meters per second. Third is also done and dusted. Shall we go to number 4? Okay. A particle P of mass 0.2 kg lies at rest on a rough horizontal plane. Okay. A horizontal force of 1.2 Newton is applied to P. So let's say in this direction 1.2 Newton. A. Given that P is in limiting equilibrium, so there is something stopping, and which is find the coefficient of friction, that means frictional force between P and the plane. Okay, find the coefficient. Oh, that makes because it's in equilibrium, these two forces will be equal, and we'll use the same relationship we used in previous question. F net, which is equal to MA, is the applied force minus resistive force. So M is 0.2 A, and acceleration we don't know yet. Oh yeah, we know 0, because it's an equilibrium, there is no motion, so acceleration is 0, is equal to applied force, which is 1.2 minus frictional force, which is written as coefficient of friction multiplied by the normal contact force R. In this case, there will be a weight of 2 kg, 2 Newton, and there will be a R which will also be 2 Newton, because this particular weight is not going down or going up, it is stationary in this direction. So 2 in place of R, I will write 2, so this is 0. 1.2 minus mu and R is 2. So 2 mu will come here and become positive, equal to 1.2. Mu, it will be 1.2 divided by 2. 0.6 is the coefficient of friction. Part B. Given instead the coefficient of friction between P and plane is 0.3. Find the distance traveled by P in the third second of its motion. Okay, so the drawing was like this. This was the particle, and here we have 1.2 newtons. Weight is 2 newtons, and this is also 2 newtons with R. Okay, now we have frictional force here, which is mu R, and this time mu they have given as 0.3, not 0.6 like part A. Find the distance traveled by this. For that we need acceleration, so we'll again use MA equal to applied force minus resistive force. Mass is 0.2 kg, acceleration we have to find out. Applied force is 1.2, and resistive force will be this time 0.3 times R, which is 2 newtons. Okay, so 0.2A will be 1.2 minus 0.6. 0.2A equal to 0.6. So A is 0.6 divided by 0.2, that comes out to be 3 meters per second square. However, we are being asked to find the distance in the third second, not the whole distance. So let's try to visualize this. In 1 second, because it's accelerating, so suppose in 1 second it traveled this much. In 2 seconds it traveled little farther, and after 3 seconds it traveled even farther, right? So what is my plan? That I will find from here to here what is the total distance traveled in 3 seconds. Then I will find what is the distance traveled in 2 seconds, right? I will subtract from this distance, and I will get the one traveled in third second. So S equal to ut plus half at square. This is what I'm going to use for both the cases. So first, 0 to 3 seconds. S, we don't know, but we know it started from rest. So 0 plus half, acceleration we got 3, time till 3 is 3 seconds, so 3 square. So S comes out to be how much? 1.5 times 9 will be 1.35, not 13.5 rather, 9. 13.5 meters. Okay. Now 0 to 2 seconds. S equal to 0 plus half, acceleration remains 3 but time is 2 seconds. So again 1.5 times 4, 6 meters. So from 0 to 3 seconds, 13.5 meters. From 0 to 2 seconds, 6 meters. So distance traveled in the third second will be 13.5 minus 6, which is 7.5 meters. That's the answer for this. Okay, question number 5. A particle of mass 0.5 kg is projected vertically upwards from horizontal ground. Okay, so this is the horizontal ground and it is projected upwards at a speed of 25 meters per second. Find the speed of A when it reaches a height of 20 meters. Okay, so U is this and V is to be found out. Okay, so we know that V square is equal to U square plus 2AS. In this case, V we have to find out. U we know, 25 plus 2 times acceleration. Since we are projecting upwards, because of the acceleration downwards, it will decelerate. So 10 meter per second square will be the acceleration will take. So minus 10, opposite direction. And distance given is 20. Yeah. So V square equal to 625 minus 20 and 2400. 20 times 20 is 400. V square equal to 225. V is 15 meters per second. Okay. When it reaches a height of 20 meters, it collides with a particle B. Okay, so this is the ground. Particle A went 20 meters up and collided with B of 0.3 kg. That is the mass of. So M of A was how much? We'll have to see. 0.5 kg. Mass of B is 0.3 kg, which is moving downwards on same vertical line with a speed of 32 meters per second. So B is coming down 32.5 meters per second. This is going up at 15 meters per second. Okay. In the collision between the two particles, B is brought to rest. Okay. So final velocity of B is 0 meters per second. Initial velocity was 32.5 and it was downwards. Okay, the initial velocity of A is 15 meters per second upwards. What happens to it? Okay, show that the velocity of A immediately is, we have to show this, we can't use it, 4.5 meters per second. So we will use conservation of momentum. which is that ma ua plus mb plus ub has to be equal to MAVA plus MBVB. Okay, the momentum, the sum of their momenta before, oh, did I plus? No, it will multiply. Before collision will be equal to the sum of their momenta after collision. So MA 0.5 times 15, it is going 15 upwards. So I'm taking upwards positive, keep in mind. Plus 0.3, but this is going down by a 32.5 meters per second speed, equal to mass 0.5. We don't know, this is being asked, right? Velocity of A, we have to show that it is 4.5, so we can't use it. Okay, plus MB 0.3 and VB is going which direction? Instantaneous arrest 0. So this is gone. So we know this, so we can simply multiply this. 15 times 5 is 75, so it will be 7.5 minus 97.5 minus not 99.65, 99.75. Okay, yeah, equal to 0.5 VA. So VA comes out to be how much? Minus 2.25 over 0.5. Okay, and equal to VA. Okay, so this will be double of 2.25, which is minus 4.5 meters per second, and negative direction was downwards, right? This 32.5 is downwards, so it will be 4.5 meters per second downwards. Because the sign in front is negative, it's shown downwards. Okay. Find the time interval between A and B reaching the ground. Okay, so we know that this was the ground and both of them were 20 meters above the ground. Okay, so you should assume that it does not, okay, it does, the one which doesn't bounces first does not hit the other one again, so we'll assume that. Okay, so time difference only, so we have to find how much time is the difference between them. So let's find for A first, which is at B is at rest. A is coming down with what speed? We just found out, 4.5 meters per second. So this is U for A. We'll do for B here somewhere. So S equal to UT plus half AT square. S is 20 meters in both cases, 20 equal to U is 4.5. So 20 meters is going down, 4.5 meters is downward, so both are taking it positive. Time we don't know, plus half. Acceleration is also down, so this is down, this is down, acceleration will be taken as positive, and t square. So what do we get here? Let's bring this also because it's becoming a quadratic equation. So 0 equal to, I'll write this one first, 5t square plus 4.5 t minus 20. This can be divided by 5, right? Because it is becoming a little bigger, so I'll divide every element by 5 so that my equation becomes easier. 5 divided by 5 is 1, so t square plus 0.9 t minus 4, and 4 cannot be factored into 0.9. that means we'll need quadratic formula for this. So t will be minus b. I hope you understand, this is a for me, which is 1, this is b, and this is c. So minus 0.9 plus minus b square, 0.9 square minus 4 times A times C over 2 times A. So minus 0.9 plus minus 0.81 plus 16.81 over 2. So I think 16 to the square root will be about 4 point something. So I'll take the only positive one, otherwise it will be a negative time. So I'm ignoring negative, only positive will be taken. I'm using my calculator to find this time. Let me do this, and by the time I do this, I would request you to kindly like this video, share with your friends, and subscribe to Math United. I'll prepare many more videos for you like this in coming days. What I'm getting is 1.6 seconds exactly. Good. So let's say for B, same formula, S equal to ut plus half at square. S is again 2nt equal to speed is 0 because it came to rest after collision. T we don't know. Half 10 t square. So this is 0. This 2 and 10 cancel. So 20 equal to 5t square. This one is easier. So 5 and 5 cancel. T square equal to 4 and square root both sides. Time cannot be negative. So time will be 2 seconds. Obviously this will hit the ground first. This will hit the ground later. But they're asking us find the time interval between A and B reaching the ground. So time interval between them reaching to the ground will be 2 seconds minus 1.6, which is 0.4 seconds. Okay. Number 6. Number 6 says that a railway engine of mass 120 kg is towing a coach of this 1000 kgs up a track. Okay. And alpha is the angle of the track. So let me try to visualize this. Okay, this is the track. This is the angle alpha. They have given sign alpha also, so we don't have to bother what is alpha. So first the engine is there, then it is towing a coach. Okay, so the mass of the one is 120 kg. This one is 60 k. So total 180 k is the mass of the two. Okay, there is a light rigid coupling. Okay, this one, which is connecting them parallel to the track, connecting the engine and coach. The driving force produced by the engine is this. So force applied is 125. Let me write straight away the number. 125 kN. And there is a constant resistive force 22,000 on engine. So there is a resistive force of 22 k on engine and 13 k on the coach. We don't have to bother about friction anymore, air resistance anymore. Total is this. Find the acceleration of the engine and find the tension in the coupling. Okay, so let's do what? Because we don't know the tension yet, so we'll include the whole of the system. Let me include whole of it and find acceleration. We already have used this F net, which is mass times acceleration is applied force minus resistive force. Correct? That's what we're going to do. Mass, because we're taking the whole system of this, whole of it. So mass of both of them is 180 k. So 180,000 A equal to applied force is given 125 k. So 125,000 newtons minus, what are the resistive forces? 22,000. There is 13,000 also in this system. And there will be a component of their masses. Total mass is 180. So it will be 180,000 180,000, and there will be one more zero because of the weight, and component will be sine alpha. This is the component of the weight which will also resist. So we will write this also, 180, 1, 2, 3, 4, 5 zeros, and sine alpha. Let me try to, all of them have zeros, so cancel zeros. Divide all of them by 1000 so that our calculation becomes easier. Okay, so 180A, 125 minus 35, 90. Minus, for that I will need 180, 00 times 0.02. Okay, so 36, 18 times 2 is 36. So then 2 zeros will go, so 36 only. 180A equal to 90 minus 36. A equal to 54 over 180, which is 18 times 3, 54. 0.3 meters per second square. So find the acceleration of the engine. This is the acceleration of the engine. Now we have to find tension. For tension, what should we do? We should focus on one which is easier, which has lesser number of. Okay, so I'll take this engine only. Okay, so tension in the coupling, I can use this system only, and that will also give me the answer. So same I'll use here. MA, which is F net, is equal to F applied minus F resistance. Mass in this case, because I'm focusing only on the engine, its mass is 120K, 120,000. Acceleration is known to us now, 0.3. Applied force is 125 Newton, 125,000 newtons, right? Minus resistive force on the engine only. There is a resistive force of 22,000. And there will be a resistance of its own weight only, not the other one. Only this one. What was the weight of this? 60? No. 120K was the weight of engine. So it will be 120K, and then multiply by 10, which is becomes the weight. This is mass, this weight, and then sine alpha. Also, we have the tension in this coupling, which they are asking us to find. So tension is also in the opposite direction, which is trying to reduce this. So let's take it T, tension. Okay, everything is with us now. 125 upwards, 22 tension, and its component. Okay, so 12 times 3 is 36, and 1 0 will go, 36,000 equal to 125 minus 22 is the 103,000 minus T, and this is 0.02, right? This one. So 0.02 multiplied by this will be 24 minus 24, 2 zeros gone, 1000. Okay, so 36,000 minus 103,000 plus 24,000 is the tension, and it will be how much? 7. Okay, 43,000 newtons. Yes, 1943. Okay, so that's the tension. What else? Find the acceleration engine. Done. At an instant when the engine is traveling at 30 meters per second, it comes to a section of the track inclined upwards at angle beta. So different angle now. This is beta. So we can't use alpha anymore. The power of produced is this much, and as a result the engine maintains a constant speed. Okay, so what is 30 meters per second is the instant when it started here. Okay, so we know that power is the applied force multiplied by the speed. So power is given to us 5 zeros, 45 and 5 zeros equal to applied force times 30 meters per second. So divide this by 30, this 30 goes, so 15 and 1 0 gone. 1 2 3 4 50,000, 150,000 is the applied force. Question: assuming that the resistance forces remain unchanged, so resistive force on engine and coach together were 22k plus 13k. Yeah, this was the one. Find the value of beta. Okay, so let's see. This is the system again. Applied force now is 150k. The resistance is 22 and 13, 35k. And then we have what was the mass of the two? 120 plus 60. 180 was the mass of two. So I'm assuming them as one body, okay? So the mass was 180k. So they will have one force in this direction, which will be 180, 180k, and then 10 and sine beta this time. Okay. These are two forces. I have taken care of resistive forces and this and applied force. So I can use them here. So minus, okay, it's already given here. So, okay. So what are they saying? Find the value of beta. So we know that MA again equal to applied force minus resistive force. Since they said it maintains a constant speed, that means this 30 meter per second stays, acceleration becomes 0. So MA will become 0. Applied force we got is 150,000 newtons. 150,000 newtons. Resistive force is 1 is 35,000 and 1 is 180,000 times 10 sine beta. Okay, so these two can 115,000. So okay, we can cancel zeros again. 3 zeros cancelled here, 3 zeros here. We divide the whole equation by 1000 so that our calculations become easier. So 150 minus 35 is 115 negative. When it goes to the left side, it becomes negative. This will be minus 180, no, 1800 sine beta. So sine beta is minus 1, rather we can cancel the negatives, so it will become just 115 over 1800. So this can become beta because they're asking us to find beta. The angle beta will be sine inverse 115 over 1800. Let me use my calculator. By the time I do this, I would request you to kindly subscribe to Math United, like this video, share with your friends. I'm going to make many more videos in coming days. So what I'm getting here is 3.66305 degrees, which we can write 3.6666. Okay, 3 significant figures. What degree is angle? Angle is shown in one decimal place, so 3.7 degrees we can write. Okay. Question number 7 and the last of this paper is this. A particle x travels in a straight line. The velocity of this is given with this equation. Okay. The acceleration of x is 0 at t equal to p and t equal to q, where p is greater than q. Find the value of p and q. So acceleration. So to convert velocity equation into acceleration, we will have to differentiate velocity equation by with respect to time. So this will be minus 0.3 t square, right? 3 multiplies with this and goes down by 1. Similarly, 2 multiplies with 1.8, which is 3.6, is positive t. Yeah, minus 6. This is the equation of the acceleration. They said this is equal to 0 at 2 times. That means we have to solve this equation and we'll get our times. So let's get rid of this 0.3. So let's divide whole equation by 0.3. This is always a smarter way of minimizing your calculations, though most of the job is done by calculator. But if you do it, it becomes even easy to input your numbers, so there are less chances of getting a mistake. So we get t square 12, then we have 20 minus 20 equal to 0, and 10 times 2 is 20. So t square, I'm breaking the middle term, so it will be plus 10, yeah, plus 10. Sorry, it is not working, so I think I made a mistake here, because plus divided by minus is negative, so I have to put this also negative. Now it makes sense. 10t minus 2t minus 20 equal to 0. t minus 10 minus 2, t minus 10 equal to 0. t minus 2, t minus 10 equal to 0. This gives me t equal to 2 and t equal to 10. Which one is which now? P is smaller and Q is bigger. That means P is 2 seconds and Q is 10 seconds. Got the values of P and Q. What next? It is given that the velocity of x is 0 at t equal to 14 is given. So if we can verify this by substituting it in this equation. Just put t equal to 14 and you must get a 0. Since they are given, I'm sure it is 0. Alright. What next? Find the velocities of x at t equal to p, which is 2 seconds and 10 seconds. And hence sketch the velocity time graph of the motion between 0 to 15 seconds. Okay. So let's do what? Find the velocities. Okay. So we have the equation v equal to minus 0.1 t cube plus 0.1.8 5.6. 1.8 minus 6 plus 5.6. So find the velocity at t equal to 2. That's what's saying. So velocity at 2 will be minus 0.1 2 cube plus 1.8 2 square minus 6 times 2 plus 5.6. So you can use your calculator for this. I'm just trying to do it mentally. 7.2 minus 12 plus 5.6. So this is 12.8 minus 12. Okay, minus 12.8 plus 12.8, which is 0. So 0 meters per second. It is stationary at t equal to. So stationary at t equal to 2. Let's talk about the other one. V at 10 will be minus 0.1 10 cube plus 1.8 10 square minus 6 times 10 plus 5.6. So which comes out to be 1000 minus 100 plus 180 minus 60 plus 5.6. So minus 160, 20, 5.6, 25.6. At t equal to 10. So, okay, now we have to draw a graph also. Okay, so let me draw the graph here. So this is my y, or let me erase this one and get more space. Okay, so we want from 0 to 15. So 0, we don't know the speed at 0. So if I put 0 here, so this will be 0, 0, 0, so 5.6. So 5.6, let's say 5.6 is here. At 0, this is the speed velocity. Okay, then 2 seconds, so we have to go up to 15. So let's elongate it little. So 2, 4, 6, 8, 10, 12, 14, 16. This is 2. At 2, what was, it is 0 meters per second at 2. So this is our second point. Let me put them again. Okay, then velocity was 0 at 14 also. So 14 here also it is 0. This is 10. At 10, it is 25.6, so it is quite high. Let's say it is somewhere here. It's a cubic equation. Since they have clearly said that it has an acceleration 0. Acceleration 0 at t equal to 2 and 10. That means these two are the turning points of VT graph, because acceleration is 0 there. Rate of change of velocity will be 0 at 2 and 10. So our turning points are there. So my graph should be turning at 2, turning at 10, passing through 14, and we have to drop to 15. 15 is somewhere here, right? So you can draw this graph and we can ignore the negative time. This is the graph, VT graph for the given situation. Okay, what next? Find the total distance traveled by x between 0 and 15. Okay, so that means we have to find the area under curve here. Here, this will give us the distance here. Distance is the area under curve. Only the problem is that this distance will be negative, which is below t axis. So we'll find the area positive. That's good. We'll find the area this one and we'll add them. Even though this will be negative, we'll add them. Just keep in mind. So that means I have to, for displacement, I have to integrate velocity equation, which is minus 0.1 t cube plus 1.8 t square minus 6 t plus 5.6 plus c. It's not c, dx, dt. This case dt. Okay. So s equal to minus 0.1 t to the power 4 and over 4. So plus 1.8 t cube over 3 plus 6 t square over 2 plus 5.6 t plus c. And we have to find this from 0 till 14 once, 0 to 14 once, and then we have to find the absolute value of what is after that. So same, but from 14 to 15. We know it's negative there. The same thing I will write here and find the distance. Okay, so let's do one by one. Okay, can I simplify this? and distance. This time I can write distance. Simplify this as well as substitute 14. So 0.1 divided by 4 will be 0.025 minus 0.025 14 to the power 4 plus 0.6 14 to the power 3 plus, no, one of them is negative. This is negative. Negative 314 square plus 5.614. Okay, and there's no need to write c in definite integrals. C gets cancelled out, and because there's 0 and everyone has t, so there's no point of substituting 0 because we'll get a 0. So this is the distance from 0 to 14, but here we will need exactly this, but with substitution 15. Okay, so minus 0.025 15 to the power 4, and we have to find absolute value of this, plus 0.6 15 cube minus 315 square plus 5.6 times 15, and it's plus minus, and whatever I get from here, because I'm substituting 14 after that, right? I have to substitute 14 and I've already done that. Whatever value I'll get, I'll subtract it here. So, and then we have to absolute it. By the time I do this, I request you to like this video, give it a thumbs up, share with your friends, and subscribe to Math United. This will motivate me to make many more videos like this in coming days. So what I'm getting here is 176.4 for this whole bracket, plus there will be absolute. For substitution of 15, I'm getting 168.375 minus, then the same, this value was to be written here also, so minus 176.4. So we get 176.4 plus absolute of minus, this will be minus 8.025. And since because of this absolute, we knew that it will be negative, so we have to make it positive. We have to add it actually, because distance is asked, not displacement. So the answer is 174 meters, but we have to round out to 3 significant figures, so we can write 184 meters. I hope they have not asked. Okay, total distance, that's it. Yeah. So this is the conclusion of this solution video of paper 42 winter 2023. I think this is the first solution video on internet. I hope you liked it. If you did, give it a thumbs up and share with your friends and subscribe to Math United. Thank you very much for your attention.